Hello, I am here with a new video of me doing calculus. I was gonna do my homework, but I did not notice it was that challenging until just right now. So I'm not doing it right now. I'm gonna practice my integration by parts. So I'm just gonna have like the integral right now. Let me get a better marker, black marker. I'm just gonna be doing practice problems. But I am gonna talk about my week. How it went. Yeah. So it was a busy week. It was annoying, like always. But to be honest, like I don't dislike my days at school. Like I enjoy school, cause every day is like a new experience, and I enjoy that aspect. By the way, I'm gonna use the integration by parts technique by blue pen, red pen. Let me make sure that I have the name right. My bad, it's not blue, it's black. So I'll put it here in blue if you want to check out the channel. Because their videos, his videos are amazing in teaching calculus. Trying to make the YouTube logo. It's kind of hard. I'm not gonna lie. Yeah, something like that. There you go. Black pen, red pen. Great channel for calculus, to be honest. He talks about like the basics of mathematics and all those things, and he goes over proofs and everything. But one of his things that I've focused on was his DI method, which, if you don't know, D is just deriving. I'm not gonna write it because I don't know how to spell derivatives or derive. And I is for integration. Integration, yes, I know how to spell because I unfortunately use it for writing essays. Yeah, but yes, it's a very powerful algorithm that I don't know if he made it, but he makes videos on it. So I'm not gonna say him that he did. Honestly, if it was me I'm a consumer of his channel or a consumer in general, I would assume that he made it. But I'm pretty sure that honestly, I don't know. I'm just gonna say he definitely made it because I don't know. But yeah. So here we're doing integration by parts, like I said. And integration by parts, you can do the DI method, which is just an algorithm, and you have plus, minus, plus, or addition, minus, positive or negative or positive, and that indicates the row, the column, not the yeah the row. So it goes diagonally. As soon as you have your function that you want to derive, and you already integrated, you're gonna use it as a row. I'll show you as this one as an example. I'm not a really good explainer. That's why I'm making these videos, because I want to learn how to explain. And it takes practice. Like, it's not a skill that I was like born with. It's really hard to explain things, because sometimes people are from like different backgrounds and different mathematical backgrounds, and I'm in that background where like I don't know what level they are, so I'm just assuming things, which is bad for teaching or like tutoring. But I think I ask them first what are the basics, and that helps me a lot. But I'll move myself here. So I don't know if the camera can record from all the way over here, so hopefully it can. Let me get the mic. There it is. So D. Let me get a better mic here. I'm gonna integrate this and talk about my life in a bit, so you can skip ahead if you don't want to do like learn this aspect. Very powerful algorithm. Check out the channel, please, because without them, I don't know what I would have been doing right now without them. And the math sorcerer. Also, that's a great channel. He recommends great books. So here, I think I'm gonna use 4x as my derivative, the thing that I'm gonna be deriving, and my cosine of 2 minus 3x dx. So I'm gonna do it for 0 cosine negative 1/3, because I'm already doing u sub, by the way. U sub, the u is 2 minus 3x, the du is, by the way, I already derived here, so I'm just left with dx, and I'm already isolating the dx, so I can have this to replace the dx. If it explains properly what I'm doing here. So I'm just gonna be, I'm a fool. I don't know why I made a fraction. I was like, skipping steps there, definitely. Yeah, but here we have the integral. So an easy method when integrating cosine and sine is just make a graph. Sine is always like vertical, or the vertical axis. Negative sine, and cosine is the axis. Yes, that's a good example. X and y. X is your cosine. I'm not adding the x like right here, because I don't know. I don't feel like you have to. Like, you do have to, but I usually skip out because I want to save ink for my pens. I use pens for math. I stopped using pencil because I've noticed that when I take notes in class, for any of my classes, and I use single sheets of paper. Example here. Single sheets of paper. I've been stapling things now, which is a great way to organize your notes, to be honest. But I've been using pens because I kept getting annoyed because of I use mechanical pencils to write. I used to write with mechanical pencil, but I noticed that like everything gets like smudged all over the thing, and I was so upset when that happened. And I vowed to myself, I'm not gonna use pencils anymore when I write notes or do math in general. Because the only time that I use pencil is during exams. Because you make a mistake, you have to erase it. Or sometimes I've used pen, but it looks messy. I have to like scratch out things, and there's many times. For great example, last week, I think I was talking about it on the last video, where like Man, I messed up on the quiz because I used the wrong variables. I was doing all, like, the math was technically right. Like, the algebra manipulation stuff was right. The substitution was absolutely wrong. So that got me very upset. Let me check if I'm recording. It's been 10 minutes. Okay. So let's continue on here. So okay, let's talk about derivatives first for trig functions, specifically sine and cosine, because they're the easiest ones to explain. So here, for me, what I think for derivatives, it relates to time. Integrals also relate with time, but derivatives relate more with time. I don't know why I'm saying this. They both relate to time. Integration is just time in a fixed, like, two locations, and derivative is at one spot, to be specific, as the tangent point touches there. But yes. But regardless, for derivatives, I think of a clock, because literally it's like a clock. It goes clockwise, the derivatives. So, for example, I'm gonna put it here. Black. Goddamn. These these markers don't have ink. Let me check the other side. By the way, I wish this was my board or my room, because I would love to have a board like this. I think my dad got me one, because he does auctions, and he resells things. But I think he got me a whiteboard. I don't know if he got it for me or he's gonna end up selling it. So I don't know. But I was talking about it, and yeah. Oh, this one looks promising, to be honest. Okay, black, I'm gonna emphasize as the arrow is equal to arrow, black arrow. Black arrows are gonna be for derivatives, okay? I'm just gonna put dy or dx. This is not mathematically relevant, but it's just an illustration, to be honest. So here, it's this. Sine's derivative is, the derivative of sine is cosine, and the derivative of cosine is negative sine, and the derivative of negative sine is negative cosine, and the derivative of negative cosine is sine. That makes basically a clock that goes clockwise. Integration is just basically everything backwards. Counterclockwise. There you go. Counterclockwise. And for counterclockwise, I'm gonna do green. I don't know if the camera can see it, honestly, so I'm sorry if you can't see it, but I'm just gonna use green for the integral. And I'm gonna use the integrand sign for integration. So integrals, so let's start with the top. The integral of sine is negative cosine. The integral of negative cosine is negative sine. And the integral of negative sine is cosine. And I forgot the cosine. The integral of cosine is sine. So there you go. This is a great reference, to be honest. I use it like a lot because it's a lot to remember a bunch of things in math, because bunch of memorizing. And to be honest, I don't like that aspect of math sometimes, memorizing, because honestly it's a bad thing, memorizing. But I do like the logic aspect of math. That's why I plan to pursue math as my long journey into my adulthood. Yeah, and hopefully I could be a professor eventually, one day, or minimum high school teacher. That's like pushing it. I don't want to be a high school teacher, but it would be a great experience, to be honest. I don't know. It's hard to say. 'Cause I can't tell the future, and yeah. So let's continue here. So since we said cosine's integral, we're using the green arrows. The integral of cosine is sine, so this is gonna be sine of whatever's inside. I'm gonna use u because it's way easier to use u. And by the way, here u, let me use the blue marker to like break it apart here. Sure arc. Here u is 2 minus 3x. By the way, I'm getting these practice problems from Paul Notes Calculus 2 question sets. And that's a great, reliable resource if you want to be practicing math in general. I think he has stats, Calculus 1 and Calculus 2 and Calculus 3. I don't know about other stuff. I haven't really checked it. I think he does have linear algebra. I don't know, but I'm gonna be doing that next semester, linear algebra. So you're gonna be able to watch me do linear algebra. But hopefully I will get started ahead of time. So let's start here. Let's continue. By the way, we can add the signs already here. Okay? And we're gonna integrate one more time because when we have our d as a polynomial, and that polynomial can go all the way to 0. Polynomial, yeah, great, polynomial, yes, polynomial. I was thinking of polynomials, yes. Polynomials are just powers. Like anything that can be derived by the power of it, and it reaches 0, that's a great indicator that that might be, I'm not saying it will be, because there's been instances that I've done it and it has not worked. So I had to restart everything again. So yeah, but for this instance, it does look like it's gonna be working. To be honest, I think there's another thing called lineups. No, lights. I don't know what it's called, honestly. I don't use it. It's for integration by parts, but it tells you logarithms, inverse functions. I don't know, honestly, the acronym. So I just use DI, which is a great algorithm, to be honest. And one day I hopefully will be able to prove it. But it does use the same principles as the integration by parts. So it's mostly in each textbook. He did say it's the same thing. It equals the same thing. So and I'm pretty sure it's the integral of u dv, which is equal to uv minus integral of dv du. I think that's it. That's the formula. I don't really use that, to be honest. I just use the but in principle, it should be the same thing as that. I'm just explaining, but yeah. So let's do this one. Let's integrate one more time. Since we already established that this is going to be -3 in the bottom, this is going to be 1/9, not negative. Because we already have a negative here, and we're multiplying by a negative, which that gives us a positive. And since we established here that sine's integral is negative cosine, it is going to be a negative. So I deleted the negative for no reason. dx. Well, you don't have to put the dx. I put the dx here because we're going to integrate again. But this has been integrated as its final form. And I'm going to use blue marker to indicate the arrows. We could have integrated one more time, which I'll show you what happens if we do that. Negative, there's going to be 2 negatives. 3. Because cosines. Mm, to be honest, it can be positive. Correct me if I'm wrong, but it could be positive. Because the fact is that since we're looking at sine itself, the negative is separate. It's a separate identity. Entity, not identity. That's why I haven't done the other homework, because I have to practice my identities for trig functions. It's all trig sub and other stuff after that. Oh, I thought it was gonna have something else. No, it does not have particular functions. Yeah, particular integration by particular functions. It's a, my professor explained it so beautifully. Like honestly, I wish I had more sleep that day because I was drowsy, very drowsy that day. But regardless, if my integral was wrong, I'm sorry. I do make mistakes. I'm human after all. um, the reason why I stopped here because if we integrate it, we're multiplying by 0, so that gives us a 0. But let's finish it off so I can talk about my day. Here I'm gonna put the solution basically for this. So I'm just gonna get on my knees and write it down. 4x minus. It's not minus. It's when we do the arrows, we're multiplying, by the way. So this is gonna be a negative 1/3 x of sine, and I'm just gonna substitute it 2 minus 3x. And here we're gonna do it one more time. Since we have a negative here and a negative here, we can multiply them and that'll be a positive. So that will be 4/9 cosine, yes, of 2 minus 3x. And that would be our solution. That should be our solution, to be honest. I don't know if it is right. Because you can simplify it. I don't know where you can simplify it, but let me check the solution. But today was an eventful day. I went to a TEDx talk for like 4 hours. It was very, 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 very like tedious. I was getting very tired after like 3 hours or 2. And I wasn't even speaking. I was getting tired for the people that were speaking. And the coldness was also an aspect there. Like that was getting me. That was kind of helping me stay awake, but yeah. But the TED Talks were amazing, like honestly. And there was one that I like missed for the majority of it. It was about I don't know what they talked about. It was a MD, medical professional. They were doing a speech. I missed it because I went to the bathroom and I was kind of scared going into stage again because I did not want to make so much noise. And I just whipped out my 3DS and started playing Kirby Deluxe while waiting for someone else to get out and letting people inside because I did not want to bother anyone. But yes, that happened today, and I was helping cleaning up and all those good stuff. Oh yeah, I was gonna check the solution. I forgot about that. Yeah. Honestly, I might do 2 more. 2 more solutions and that's it. We got it, guys. We got it. Yes, we got it. Okay. I hope that helps you go to this channel and find more content from him because great YouTuber and great professor. I think he's a professor, to be honest. Let me think. yes, he is a professor. I think Berkeley University. I don't know. I'm not professor, so yeah. I'll leave it here for a while. After the second one, I'll erase it. I was gonna say, let me copy all this because I had to write it for my notes. But I do not have to. I almost dropped out. My bad. But yeah, I just woke up from a nap like a couple minutes ago, so I'm still saying that as an excuse. Um, Here's another one. This time it has bounce, and not a big fan of bounce, like definite integrals, but I don't mind it. Like same thing, honestly. 2x plus 5 of e to the 1/3 x dx. I've gotten so many, like, I lost so many points during like assignments because I never put dx. Bad habit of mine, which I should change. And here we can do one of the properties of integration where if your a, I'll write it down here, a and b. If a is greater than b, you can do, let me write it down. If a is greater than b, then you can use the which is you can swap them and multiply by a negative. I'll have it here for like 5 seconds. You can use it as notes or something. I don't know if you're actually here to like learn or just hear me yap about my day or yap about math. But yes, I'm gonna rewrite this down. There you go. So yes, I've been enjoying things around here, yeah. And I think this one, we do not need to do integration by parts. We can just, honestly, you can do both. You can do 2 methods here. You can distribute, or you can do integration by parts. But integration by parts, I do think I'll do both, to be honest, just to see if it does work, if I'm wrong or something like that. So yeah, to be honest. I said to be honest a lot. So I'm sorry if you get tired of me saying be honest, to be honest. And I'll do the first way. Sorry if I'm really bad at spelling. No, I'm kidding. Well, honestly, I am bad at spelling, but I'm bad at writing. My calligraphy is horrible. But here we go. Here we're gonna factor. So we're gonna have 2. Honestly, yeah, you will use integration by parts regardless if you did factor. Because here we would have e to the not negative, 1/3 of x, and this signifies that we have to do integration by parts, which it's a bunch more work, to be honest. So I'm not gonna be using distribution here. So I'm just gonna use I'm just gonna have this as my D, and this as my exponent as my integration. So let's see if it works. I'm gonna erase this because we have established that that's more work, and as mathematicians, I'm not a mathematician, I'm a fake one. I say that I'm a proclaimed mathematician, but I believe everyone can be a mathematician in part. It's just a lot of practice and staying true to your craft. And honestly, I'm just saying things. But yeah, here we're gonna use D, and this is gonna be a D. X plus 5. Our I is going to be the integral. Yeah, we can say integral of. Yeah, that's a proper way of saying it. But I said rather than saying integral, rather than saying the exponent of 1/3 of x, I said integral of 1/3 of x, which gives you something else. You need a power rule on that one in that case. But here we're gonna establish let u be equal to 1/3 of x. Du is gonna be equal as, we're not gonna be dividing. Well, we are gonna be dividing, to be honest, because we're left with 1/3, and that 1/3 we can 1/3 of dx. My bad, I completely forgot the dx. Honestly, I would have been docked so many points for my instances. But yeah, I'm just gonna do it now, and I'm just gonna be talking more about the day or the week. So I became a representative for the Society of Physics in my school, which is kind of cool, but kind of daunting because I'm apparently a physics person now. By the way, this can also be written as du. 3 times du of dx. Same thing. But here we're going to be multiplying 3. I'm so tempted of talking, but I'm yapping about my explanation of how I do things here. But yeah. Yep, that works. Okay. My week was kind of stressful, but oh yeah, it was stressful. I had to write an essay, and that was the first time I was writing an essay since like almost 6 months ago. So that was kind of bad. I had we were writing about Madame Bovary for my French literature class, and to be honest, the professor's great. Everything is great in that class. We don't have many assignments, but that has been like the first assignment that he's given us in like the beginning of the semester, which is each couple weeks. I'm checking if it's recorded. Each couple weeks, we're reading like the book. I think we have like 4 books or 3 that we're reading. Madame Bovary is one of them. It's about this French lady that does adultery and dies from arsenic. Yeah. Not the best explanation, but regardless, yeah. And I had to write an essay. I've been given like 5 days to write the essay, but I was like last day, like Monday, because the due date was Tuesday, and I was thinking of what to write because I already established the idea that I was gonna write something. I had 2 ideas because he gave us 3 prompts, and we had to choose 2 of them, and it has to be a minimum of 400 words. So I did get to write 400 words times two, 800 words, something approximately. It was close to like 900 words in total, but I wasn't really counting. But yeah. Um, but I talked about a reverse gospel because I don't know, because that topic of the book is mainly about the French, and the French have been really well known in history to like have like historical background with religion. It's very connected to the culture. So I just established a reverse gospel because it's not a great life to live. You know how the gospel, I don't know how the gospel works, honestly. I'm not really a religious person, but I respect religion, but I don't know anything. I'm very ignorant in it. But I just put as a guide, like brief summary. It's like a guide to like avoid how to live life, and it, it was it was a decent essay. Like my professor said, it was a pretty good essay. But down in my heart, I said I wrote this in like 1 hour too. So it's not great like writing. He did give me critiques, which I appreciated the critiques. I'm not gonna be like I deserve higher or something like that. I did the assignment, and there are things that I could have done better for sure. And next time I will do better. Yeah. I asked them to give me feedback because that class isn't a writing class. It's more of a humanities class. But regardless, yeah, it's a humanities class, and I enjoy that class honestly. There's times where like I almost miss class, but that's because I don't know what I'm doing with my life here on campus. Yeah, sorry. I was it's kind of hard to talk about something else while like concentrating on doing something else. So, yeah. But life has been great. Nothing bad has happened. Yeah, and I'm just trying to live life without no regrets. That's and another thing. Season 3, episode 1 of ReZero got released, and man, I was excited, so excited. I was like frantically really happy that day. I like after class, I like went to eat my lunch, went to the cafeteria, ran back to my dorm, and like started watching. It's like an hour and 30 minutes, and I knew I had like a test Friday, quiz on Friday, so I was trying to finish it as fast as I could. But yeah, it was a great episode. Oh my god. Oh my god, I haven't been that excited in a while, which is kind of sad, but uh, it, it's it's hard to sometimes because I just suffer from depression. But that's like my joy in life, to be honest. I'm gonna do arithmetic here. 17 plus 17 times 3, because I'm very lazy to do simple maths. 51 of eastward minus 15. And to be honest, I'm kind of scared of making these videos because technically I can use the room as however I want, But like, I'm kind of scared someone is gonna like walk into the room while I'm like doing these speeches, or not speeches, but talking about the day. Yeah, it was a negative here, and I multiplied negative from that side. Yeah. Yeah. But yeah, and I got 100 on my quiz, which was about knot theory. Knot theory. I do like knot theory, but it's a lot of work, to be honest. And I was surprised to do that much work in like the first semester of my school year. But because for physics honestly takes up all my time. And if I'm not doing physics, I'm doing calculus. If I'm not doing anything, I'm watching YouTube religiously. Like, I'm addicted to YouTube, man. It's a problem. Honestly, it is. I'm gonna finish it up here. But, let's equal to 69 e squared. Oh, I fumbled here. Well, I'm gonna distribute the negative here. So this time we're gonna be, oh my god, 51. Guys, it's been a while since I've done like arithmetic. So give me patience, because honestly, I'm too bothered to do simple math right now. But yeah. That's someone walking right now. I was kind of scared. Yeah, it's 33. Yeah. So the answer will be 33, negative 33. E squared plus 14. That is our final answer. But yeah. And I'll do the second problem, the third problem in a bit right now. I'm just gonna talk more. Yap. That's what the people call it nowadays. I'm not that old, by the way. I'm like almost 19, so yeah. Yeah. So I had that. I finally got myself glasses because my work, it's kind of painful being outside. My work is outside. I work on like soccer games or football games. I despise the football games. They're like, it's like a lot of running, and I do not exercise, to be honest, which I should be, but I have an excuse, but it's a painful excuse, because it is actually painful to like run, because I get shin splints very easily, which I should be running more to like build that tolerance. And I think I saw UFC. They had like this rolling pin or something, and they were like going like grinding the shins, like rolling motion. And I tried it. Oh my god, I almost cried in my room. I think my roommate almost saw me doing that, and oh my god, I think that hurt more than getting hit in the balls by like a football. Yeah. Yeah, because it was constant pain. And oh my god, I did it for both of my shins, because I think it was after I saw the video clip. I did it with my shins, because I was telling myself I'm gonna do it each day so I can do a tolerance, and I can increase the like my shins, like my durability of my shins. Because yesterday I worked, like I did 2 soccer games. One was for the men's and one was for the women's. I was exhausted, very exhausted, but honestly I couldn't run that well anymore, because also I like I don't know what happened there, my right leg is like kind of messed up, which I'm not gonna really run that much anymore. I want to try to heal it as much as I can before my next shift, which I do not know, and I was gonna go with friends yesterday. I had plans and everything, and so I checked my schedule, and yeah, my work was like at that time when we were gonna spend time. Yeah, yeah, so I had to cancel, sadly. Uh, but the games were like we lost, like my school lost in both of them, but it was like by like 1 point, I think, or 2 points, which is significant, the 2 points, but 1 point is like okay. But yeah, and I also bought this yesterday, which is the Beretta water bottle filter. Yeah. Because here on campus, I'm kind of scared of drinking the water from the water fountain, because there was one time that I did drink the water because I said, oh, it's not gonna be that bad compared to like where I'm from. Oh my god, I felt like I like ingested like mercury and lead in the same time in that duration of drinking the water. It was really terrible tasting water, also. And I bought that filter. The filter was like, it was like exponentially like getting better, or logarithmically getting better. Yeah, because it did filter a bit, then it was getting better and better, and it's already like reached like it's asymptote or something like that. Asymptote. I forgot I have to get like farther away from the camera because it cannot see me. Yeah, my hand. By the way, let's check this out. Hopefully it's not in decimal form because I'm just gonna whip out the calculator if it is in decimal form. Yeah, something went wrong. Definitely. I don't know what went wrong here. Two. Sorry, I'm just checking what went wrong. I cannot speak. It's been very apparent that I cannot speak. Yeah. Mm. Yeah. I see. Honestly, I don't know what to do here. I'm gonna assume my answer's right, but there's a chance that's wrong. Actually, I have my calculator with me. Well, my calculator's across the room. But I'm kind of glad that my high school teacher did not let me use a calculator that much to doing integration or derivatives. He was like very practical with like what we had to do. Like he wanted us to like do the work basically, not the computer do the work, because a bunch of teachers, specifically my computer science and my calculus AP calculus teacher, like said, don't use the calculator. And I think someone like would say, but what if we can't do the math in our head? Or something like that. And he says, I think someone asked for like a calculator and they said that you are the calculator. And it's funny, yeah. Let's see if my thing can actually integrate. Okay. Yeah, but regardless, my life has not changed really much since like a week. Yeah. I'm gonna compute this. We're really close to the answer. The answer for this one gives us negative 229. Yeah, 229.839. And this, integrating by calculator, gives us negative 46.83, which I don't know what happened. We're really close to the answer, to be honest. Because I think the E was right. I don't think the subtraction was right. Yeah, subtraction should be right. I see my mistake. Yeah, here it is. This is the process of math, guys. So here I made the mistake, the critical mistake of assuming that we only had E, the exponent of 1/3 of x. And I forgot about the 18, so this would have been 18. Yeah. Which hopefully gives us the answer this time. Something close to the answer. Since we have 18 here, not 1, this should give us negative 3. Negative 3, and let's calculate it in the calculator to be sure. Negative 33 e squared minus 3. And yeah, we got it. Yeah. Yeah, be careful when you like substitute. That's like my worst problem in math and physics. Substitution, guys. I'm horrible at substitution apparently. But yeah. The answer sheet is 246. Negative 246.839. Let me write it down. Approximation. I don't know what happened to the other marker. The other marker. I don't think this one. Yep. I'm just gonna deal with this one. Oh, I'll use the blue one. There we go. Which we established will be 49.839. I think so. 46. Yeah. That's a good way to like verify if you're integrating or deriving right. Just as soon as you like derive everything, have your like function, you sometimes don't have to simplify. To be honest, simplification would make it easy to do the math, but if you're in a time crunch, do not simplify, honestly, in my opinion. But it depends on the professor, and yeah, my professor is very lenient with this simplification. But because he usually has it where like we have to substitute a value in. Yeah. He like horribly like he barely uses indefinite integrals or antiderivatives. But he usually uses derivatives. No, what did I just? Yeah, he does derivatives at one spot. Like he has like we did it last week. Yeah, with the Sintian cosh. Yeah, the hyperbolic trig functions. But yeah, he usually does it there, and he gives us definite integrals for sure. But yeah, I'm gonna erase it. Yeah, but we had those quizzes. Quiz on Wednesday, last week. Quiz on Friday for my FYS, my first year seminar, which is not theory. I was talking about it. It's not theory. We have like a trefoil. Honestly, I'm barely trying to remember how to like draw these. There you go, trefoil. And we're doing like factor trees. We have to give them like orientations, something like that. Yeah. Yeah, and I'll do one right here. So here we have a positive. Here when we have this occur, this indicates as L positive. And when we have this occur, it's an L negative. And when we have this, I don't know if you guys can see that. I'm sorry if you can't. I'm very sorry because I'm getting used to like video recordings. Yeah, you can see it pretty well. Yeah, and these are like the fundamental like steps, and we're doing Alexander's polynomial. Which I barely remember it, to be honest, and I think it goes something like delta L positive minus delta L negative. Let me write this over here underneath these. Delta L positive minus delta L. Honestly, I don't know if he uses deltas, to be honest. I probably uses P's. Humphreys. No, the Humphrey one uses P's. If you guys know what I'm talking about, you know what I'm talking about. I don't want to explain the rest. Yeah. And it's T minus T to the power of 1/2 minus T to the power of negative 1/2. And it's multiplied by the L. Oh, 0, my bad. Same thing. And here, since we have a positive orientation, this is going to be our L positive. And we're going to do factor tree. L positive. Yeah, and we're going to connect the yep. That should be it. Yeah, there we go. In this instance, this gives us like 2 circles, 2 knots, 2 unknots, which is equal to 2 unknots. And one of the rules for Alexander's polynomial is when you have 2 unknots, delta 2 unknots, it equals to 0. equals to 1. Yeah, 1. 1. And when you have 1 or not, it's equal to 0. Let me actually check my notes. I'm like making stuff up. Yeah, it is true. Yeah. Yeah, I'm right. Okay. Oh, I forgot to add it equals to 0. Like this equation all equals to 0. And sometimes when you have like a higher trefoil, like not trefoil, but a higher degree in knots, I actually don't know what they call that. Like higher index, some people call it the periodic table of elements for the knots because it does look like the periodic table. But yeah. But here we're gonna like continue doing it. So it's kind of harder to do these because I have to like try my best not to mess up. Okay, yeah, there we go. Ooh, what am I doing? Yeah, there we go. Honestly, I don't know if I did it right, but yeah. Because you have to like get this spot. Since we have this right now occurring and this, we want to do like something like where we get this right here. So way would be, yeah, this should be right. So we get 2 knots for these. Oh, yeah, I remember. Answer. Oh, this is 1. Yeah, right here is 1. Because you can do it right, the master move and like move it around, which is 1 knot. And here we can do the same thing. Again, we're gonna establish this as our. I'll check my notes. I don't know how I did it, I think. Yeah. Oh, because I got this, but my professor only told me to like do 1 factor tree of it. Yeah, so let me do this right now. So it's gonna be like this. I'm gonna say this is L positive, L 0, L 0. I don't know. Let's give it L negative. Yeah, this is L negative. And this is L positive. And here, some weird thing is gonna happen. Like, yeah. Let's see. Yeah, there you go. We're gonna get that, and this is equal to 0. This is equal to notes. And I think I'm gonna stop there because it's a bunch of algebra. Because you have to start here. You have to substitute these because we established this is L0. We're gonna substitute these inside these equation. These are the rules for some of the rules for the Alexander polynomial. Here, let me check if it is the notation because I might be wrong. Yeah, it is that notation, and this was supposed to be a positive. But here's it is really interesting. Yeah, interesting stuff. I'm gonna stop because I think my phone is gonna blow up or like die from how much I've been recording. It's been an hour, I think, an hour plus. But yeah, hopefully you guys like the video. If you do, recommend it to other people. Speak and everything like that. But yeah, and hopefully next video I'll just talk about myself, like who I am, and yeah. By the way, my name is Dario, and Dario or Dario, the Spanish word, Spanish accent to it, but Dario. Yeah. I have to like go like white for a moment and go Dario. Dario, but people hear Tario or something like that. I lisp a lot, so it makes it hard to speak. Yeah, but I'm doing these videos also to like get better practice on like enunciation in general, which does help me, and I think this is gonna help me in the future. Giving like small lectures, but like explanations and everything, and talking about stuff and all that stuff. Yeah, but hopefully it is still recording. I don't know if it is. I'm scared to check, but yeah. Hopefully you do enjoy this video and stay in tune for next week. Thank you.